So good morning to one and all. In continuation to the previous session, so now in this session I am going to discuss about how to sequence n number of jobs through m number of machines. Earlier we discussed how to sequence n number of jobs in 2 machines, 3 machines. So now we'll see how to sequence n number of jobs through m number of machines. There is no limit for machines also now, that may be 4 or 5 or 6, more than 3, that we'll see now. So the aim of the session, objectives and the outcomes are this. Finally, the outcome to be expected is the student should be in a position to sequence n number of jobs through m machines to minimize the total elapsed time. Now, the Johnson's rule, the same algorithm again. You know, the Johnson's algorithm can be applied only for the 2 machines. In the previous case, the 3 machine problem we converted into 2 machine problem and we applied Johnson's algorithm. Now the case is, see in the problem we have 4 jobs are there. Each job mustn't go through machines, all 4 A, B, C, D, and these are the processing times given. Now we have to identify the sequence that minimizes the total elapsed time required to complete the jobs, and also you can able to identify, you should identify the idle time for machines A, B, C, D. How to get the sequence is the question. If you want to use the Johnson's algorithm, there should be 2 machines, but here 4 are there. What to do? Convert 4 machines into 2 machines. How? By taking 2 imaginary machines G and H. G will be equal to processing times of A plus B plus C. By adding A plus B plus C, processing times will get the processing time for imaginary machine G. By adding the processing times of machines B plus C plus D, will get the processing times for the imaginary machine H. Like that, the 4 machine problem can be converted into 2 machine problem and we can apply Johnson's algorithm. So that we'll see. But before applying this, just verify the condition to apply the algorithm. One of the conditions should be satisfied, that is smallest processing time on machine A should be greater than or equal to largest processing times on machine B as well as machine number C. I have written already here, shortest processing time on machine A is 28 and the longest time on machine B is 16. In C or it is 18. The 28 is greater than 16 and 18. That condition is satisfied. So we can apply Johnson's algorithm definitely. So as I told you, the 4 machine problem is converted into equivalent 2 machine problem where the 2 imaginary machines are G and H. G will be equal to A plus B plus C, H will be equal to B plus C plus D. Okay, by taking this assumption you can able to get the processing times for both imaginary machines G and H. Now this is the problem. Now you convert the 4 machine problem to 2 machine problem by taking G equal to A plus B plus C, H equal to B plus C plus D. Just add the processing times. It's very simple. And see, like this we have 4 jobs and 2 machines G and H are there, and we know the processing times also here. Now it is a 4 job 2 machine problem. Only 2 machines are there. Here we can apply Johnson's algorithm 100%. We have only 4 jobs are there. Now let me apply Johnson's algorithm first. Out of all these 8 processing times, what is the least processing time? The least processing time here is 60. 60 is the least processing time. Is right? No. 56 is there. 56 is the least processing time out of all. Yes. This 56 corresponding job number is 3. And this 56 belongs to first machine or machine G. So where you have to place job number 3, in the beginning or in the ending? In the beginning, in the left hand side. Place job 3 here. Afterwards you eliminate this. Next, in the remaining 6 processing times, what is the least processing time? The next least processing time is 58. 58 also belongs to machine G, the first machine only. The corresponding job number is 2. Have to place 2 towards left only. Remove this. What is the next least processing time out of the 4 processing times available? It's 70 and it belongs to machine H. Corresponding job number is 4. You have to place job number 4 in the last. At last we left with only one, that is job number 1. Now the most logical sequence obtained through the Johnson's algorithm for this 4 job is 3 2 1 4. 3 2 1 4. Now we'll proceed with this 3 2 1 4. Like this, whatever the problem is, we can convert into 2 machine problem, then only we can able to apply the Johnson's algorithm. Then you can able to identify the sequence. So once you know the sequence, see the sequence I wrote here. Now we have 4 machines. Whatever the process we used earlier, the same process can be applied for 4 or m number of machines also. Time in, time out estimation. After estimating time in and time out values, at last you have to identify the total elapsed time. The total elapsed time is here, it is 250 minutes. 250 minutes. Now the ideal time for machine A will be, here a machine A is not waiting, but see the 250 minus 180. So therefore 70 minutes machine A will be idle. Coming to the machine B, initially it is 28. Next here some difference is there, 58 minus 40, 116 minus 68, 180 minus 130, and finally 250 minus 196. We have to add all. So machine B idle time will be 198 minutes. And machine C, initially it is waiting for 40 minutes, and here another 68 minus 56, 138 minus 86, 196 minus 143 plus 250 minus 208. The total time, the total idle time for machine C will be 190 minutes. And machine D, it is initially 56 plus 144 minus 30, 56 plus 14 plus 16, 84. Okay, so like this we have to identify the job sequence and also the elapsed time and idle times for the given number of machines with the help of Johnson's algorithm. Okay, only we'll use Johnson's algorithm only to identify the job sequence. Later, to identify the idle times and all, you have to adopt this procedure. Either it is a 2 machine problem or 3 machine problem or 4 machine problem, the process is same. The only thing is the iterations are only going to be increased, right? And the activities mapped to session are mentioned here. The activities or case studies. I have mentioned 2 case studies also. Implementing machine learning algorithms for adaptive job sequencing in a dynamic production environment, analyzing the impact of job sequencing on production time in a high volume manufacturing facility. And the examples also mapped here to this session, which are relevant to this session. And coming to the summary, in this session you have learnt about how to apply the Johnson's algorithm steps for sequencing n number of jobs through m machines, m number of machines. We converted a 4 machine problem, sometimes 5 machine problem also will be there. That also we can able to convert into 2 machine problem. And here we discussed how to sequence n number of jobs through m number of machines to minimize the total elapsed time. That also we discussed. And self-assessment questions in a sequencing problem involving n jobs and m machines. The primary objective is to minimize the make span or to minimize the elapsed time, the total product completion time. And which sequencing approach is commonly used for m machine scheduling problems where objective is to minimize the make span? Johnson's algorithm, that only we applied to identify the most logical sequence. And here are the terminal questions mapped to the session. These are the books to refer. Thank you very much.